YouTube channel. So today we solve the problem of LeetCode POTD, and this problem is maximum number of jumps to reach the last index. You are given 0 index array nums of an integers target. You are initially positioned at index 0. In one step, you can jump from index I to any index j such that 0 greater than is equal to I greater than j and greater than n. And in that, minus target is equal to greater than of nums j and nums of I is equal to target. Return the maximum number of jumps you can make to reach index. Right? So just explain the question. You are starting at index 0. You just have to start your index 0. You can jump I to j only if this condition is followed. We need reach n minus 1 time. We need reach means n minus 1, which means last index. Make maximum number of jumps, and in that I just have to maximum number of jumps we need to require, and we need to do like maximum number of jumps, then we will reach in the n minus 1. If possible, if impossible, then return minus 1. Right? So this is the problem. Now comes on the approaches. What you have to use this in the brute force, like what you can think as a brute force approach. So in that, we just think start, and like this we have the nums and we just reach to the end. So we can choose the different platform, that means different array of indexes. So if you are the find the pattern, try to find the pattern in that problem. So like we just have to find the different path and the maximum path till we reach in the n minus 1. So the finding the path, so whenever we just have to get problem like finding the path, we in our mind just think like a recursion. Why recursion? Recursion is the point where we have to find the maximum in that concept we just find the multiple approaches and we got the answer. The same thing here, multiple approaches and multiple that means traverse multiples of traversing, and then we reach on the maximum jumps, same as. So here we can use the brute force approach as a brute force approach is a pure recursion problem, right? From every index I, try all possible next index is j, right? Take the maximum jumps among all valid paths. रिकर्सिव रिलेशन क्या होता है इसमें से, maximum jumps need to reach n minus 1 from I, then fi is equal to 1 plus max of fj, right? So this is the concept. So yeah, this is a very slow because it will take the order of n to the power n x, which is exponentials. But yes, I just tried to write the code for your beneficials, right? Then you can understand. So in that I just write the recursion code, right? So recursion is target, and we just have it on the target and nums. So n is equal to nums dot size, and int answer is equal to, we just have to write the function of solve from 0 to nums and target, right? And then return the, and we have written the answer of 0, and if 0 then this is the minus 1, and otherwise answer minus 1, otherwise answer, right? Now I just write the function. So the first thing is int int n is equal to that is, and int is that is a global. Now int, write the function of solve, int solve of int I and vector int address of nums and int target, right? Now reach last index. If I is equal to n minus 1, then return 0, or int answer is equal to minus 1 e to the power 9, right? This is. Now for int j is equal to I plus 1 to j greater than is equal to n and j plus plus, right? Now that is the if absolute value of nums of j minus nums of I greater than is equal to uh, target, right? So we can write here like this and just remove one here. And now int temp is equal to solve of function of j to nums to target, right? If temp is not equal to 1 e to the power 9 minus, then answer is equal to max of answer 1 plus temp, right? And then return answer. Now I just check. Yeah, so check, it will just give the TLE. Why? Because it will take the exponential time. Yeah, it will take the TLE. Why? This is in that approach, which means it will traverse the all type of operations, all steps, repeated steps. So it will take the 2 to the power n time complexity. So what we can do? So the simple thing, when we use the recursion, then sample is we can use the DP for memoization, for optimization. So we can use the first is the top down approach, right? Problem in brute force, same states are recalculated many times. Use DP, store maximum jumps from index I, right? Only we just have to store the maximum, right? Each checks of end indices. Now nothing to do, a lot of thing here. I just do to the optimization thing, like we can use in the same app, same code to use DP and DP. Now int n is equal to 0. Now one more approach I just have to write here, like if DP of I is not equal to -1, then return DP of I, right? This is now there is nothing to do any, these all are the right, and just in answer like DP of I, yeah, DP of I, simple, and return answer, and nothing's more here. Now I just here to implement the DP concepts, like DP dot resize of n to the power -1, right? Yeah, now check, it will, yes, and try to submit. It will also take the order of n square, but yes, it will pass the test cases and submission. Now I just write the uh, bottom to top approach, right? So in that, what happened there, for uh, for every pair j to I, if jump valid, then dpi is equal to max of dpi and dpj plus 1, right? So in that, so I just write the bottom to up approach. That is very simple, and there's not that much lengthy here. So starting from the int n is equal to nums dot size, and then vector int of dp of n to the power -1 and dp of 0 is equal to 0, for int I is equal to 1 and I greater than is equal to n and I plus plus. Now for int j is equal to 0, j greater than is equal to I and j plus plus. Now if dp of j is not equal to dp of j is not equal to minus 1 and absolute of nums of I minus nums of j greater than is equal to target, right? Now dp of I is equal to max of dp of I and dp of j plus 1, right? And then return the dp to n minus 1, right? Now just check it will run, it will pass all the test cases or not, just showing any error, no, and submit it. Yeah, I think it will submit it successfully, yes. So this is the approach, and in that the time constant is order of n square and the space is order of n. So that is the whole approaches of the maximum number of jumps to reach the last index. So I hope you will clear your concept. So thank you for staying till the end, and please like and subscribe my channel.